Autonomous multi-agent systems represent an architectural transition. Instead of a single model responding to a prompt, these networks plan, delegate, and execute multi-step workflows. Scaling this coordinated behavior requires three infrastructure pillars: a universal semantic layer for data access, structured orchestration patterns, and span-level observability to track internal logic. When these systems operate without these pillars, internal complexity increases until the architecture fails, causing errors to cascade across the enterprise. Agents often fail when they operate across fragmented data silos without real-time context. This leads to coordination loops, where agents blindly pass tasks back and forth because they lack a shared, up-to-the-moment view of the system. This diagram shows the shift to the Model Context Protocol, or MCP. On the right, a universal semantic layer replaces tangled point-to-point connections, routing data directly to a central agent hub. This architecture feeds agents real-time metadata without data migration. The information stays in its original database while becoming instantly accessible to the agent network. Establishing this governed truth is the mandatory first step for specialized agents to collaborate on a task. To manage this collaboration, organizations use frameworks like LangGraph for stateful control, Crew AI for role-based delegation, or AutoGen for conversational coordination. These frameworks enable 5 distinct structural patterns: planner-executor, hierarchical supervisor, maker-checker, pipeline, and swarm. Comparing a swarm to a hierarchical supervisor illustrates the governance challenge. Peer-to-peer swarms are difficult to audit, while the supervisor model provides a clean routing structure controlled by a single manager node. In high-stakes fields like healthcare or finance, the maker-checker pattern is utilized to reduce hallucinations. An acting node generates the work, and a verifying node acts as a gatekeeper before the result is finalized. To achieve reliable scale, enterprises are moving away from open swarms toward these structured, role-based orchestration patterns. Cascading agent failures are a primary security risk. They occur when a single agent's error propagates through an automated chain, corrupting the entire system. A single user request can generate between 40 and 200 distinct operational spans. Evaluating only the final output provides no visibility into these internal steps. This trace tree represents a multi-agent workflow using OpenTelemetry. By scoring individual spans, the system can catch a tool call error at span 14 and halt execution before it reaches the final database. Embedding intent gates directly into the runtime provides a circuit breaker, stopping misaligned actions before they cause an enterprise data breach. IT leadership must prioritize 2 actions before deploying agent teams: implement a unified semantic layer for data access, and instrument the platform for span-level observability. Scaling multi-agent AI requires governance and data architecture to be embedded directly into the operation. Secure automation depends on this underlying infrastructure.